Good evening, Sugar Gliders. Welcome to Chapter 5, Lesson 4 on terminating and repeating decimals. Follow along as I read it out loud and fill in the blanks. Any number that can be written as a fraction is called a rational number. So let's remember, integers only included our positive numbers, negative numbers, and zero. So now we have additional types of numbers, and those are fractions, and we call those rational numbers. So every rational number can be written either as a terminating decimal or a repeating decimal. Okay, so let's take a look at these additional notes here. In words, rational numbers can be written as fractions. Remember, integers do not include fractions, but rational numbers do. In algebra, they like to take a variable, A, B, any letter, and kind of give you an example using letters where any number can be substituted. So basically, A over B means the fraction A over B, where A and B are integers and B is not equal to 0. That's just showing you that's what a fraction is. We'll get into that more into algebra later. Our model, okay, you can kind of remember the song we did. Whole numbers, integers include the whole numbers, so we have positive, negative numbers. And then included in with the whole numbers, integers, we extend that set to rational numbers. And if we look, here's a decimal. Here's a fraction. We know decimals and fractions are the same. Here's a mixed number. This is a negative repeating decimal. The 4 would keep repeating. And this is a positive terminating decimal. So let's look at a list of all the numbers that are considered rational numbers. First we have fractions. Then we have terminating and repeating decimals. We have percents, because remember, fractions, decimals, percents are all the same thing except they're in a different form of the number. We also have integers, and somebody reminded me, don't we also have whole numbers? So let's add and whole numbers as well. Okay, so to indicate the number pattern that repeats indefinitely, that means it goes on and on. We use what we call a bar notation. So bar notation is a bar placed over the digits that actually do the repeating. So if we look down here, 0.5454545454 dot dot dot, that dot 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 means it continues. Our bar notation would be 0.54 are the two numbers that repeat, and we put a bar over both those numbers. If we look at our next example, 0.58333333 with dot dot dot, so that means the 3 repeats. Our bar notation, so we don't have to keep writing all those 3's, is 0.583, and we put the bar just above the 3 because that's the number that repeats. Let's take a look at some examples on the next page. If we want to write 5/12 as a decimal, we have to remember that that fraction bar also means to divide. So we can do our division, 5 divided by 12, and remember, I'm going to kind of take this off to the side. 5 goes on the inside, it's being divided up by 12. 5 is our dividend, 12 is our divisor. Okay, since 12 can't go into 5, we add a decimal and a couple zeros. In this case, I'm going to add 3. Bring my decimal up, and now I can think 12 goes into 50 4 times. 4 times 12 is 48. Subtract, and you get 2. Bring down the 0. 12 goes into 20 one time. 12 times 1 is 12. Subtract, you get an 8. Bring down the 0. 12 goes into 86 times. 12 times 6 is 72. Subtract, you get an 8. And here's where we see this pattern repeating. If I were to bring down another 0, I still have this 80 that repeats. So we can see the 6 is going to continue to repeat. So the notation would be 5 twelfths equals 0.4166 dot dot dot, or using my bar notation, the 4-1 does not repeat, but the 6 does, so we put a 6 on top of that. So I am going to let you try the problems below. Use bar notation if it repeats, and yes, there will be repeating decimals in this example. Have a great night. Let's see how you do in the morning.